knowing like what is a role, and what are the rules, right, that a role gives you, and why would you want a role versus assigning things to a specific uh, person. But in terms of rules, this is something that I didn't get, at least my perspective, I didn't get until I realized when these things were these rules were expressed, they were actually building on top of like the HTTP requests. Is that a one-to-one mapping, Mark? And then I think you added that here, but no other places actually point that out. Like if you go to the RBAC, if I can remember, like Kubernetes RBAC, first time I learned RBAC, which by the way was like maybe 8 years ago or something. It was from a YouTube video. Apparently, that's how I learned about RBAC. I think an expert was explaining RBAC, but it after a long time, and then I realized all these things are referring to HTTP requests to the API server.
Yeah,
right?
Absolutely. And that's one of the more frustrating things about learning RBAC is that RBAC's dumb. Like it's not very smart in the way it does things. It's just matching on strings. So it matches on the string of the URL. It matches on the string of the action. Where things get really hairy with RBAC is when you start dealing with things like impersonation and user extra, because you have to include all of the things that you want to impersonate. And you can't do things like say, I want this user to only be able to impersonate these roles, right? Like it's
Yeah.
very it's very difficult to, create fine-grained permissions with RBAC, and it's only at the URL level.
Yep. And this is the audience here are very experts in Kubernetes. So here's a perfect example, right? You say resources. You're going to allow whoever has this role to get and list on resources, and you will think, well, what are the Kubernetes resources? A pod. Yeah, that's simple to understand. And then you see pod/logs. That's not one resource. That's not a type. What is that? And basically, that's an HTTP request. You do an API server /pod, you get the information on the pod. But if you do /logs, basically, you're not going to access etc. And then on top of that, you're not going to access SCD on /logs. You're going to be talking to the API server saying, "Hey, can you build me a proxy connection to the kubelet?" Right? And then the kube API server connects to the kubelet, and the kubelet is the one talking to the container, gets you back the logs. The same thing for /scale, right? Or /status. I think scale is on the where you're scaling, which is the deployment. But /status, right? Give me the status. Are you able to access the status or not of a pod? Which you can constrain.
And status in particular is really important, especially if you start writing your own controllers or operators, because status is considered a privileged component of any object. So you have to define that RBAC separately, which makes sense, because if you're going to make decisions based on status as an operator or as a controller, you don't want the user to be able to manipulate that.
And also for the controller, right? The controller will need write access to do a patch on /status, right? To update it, to put the conditions or the error, whatever information that you want the controller wants to stash in status. So you have to configure the service account of that controller, right? If it runs inside the cluster, to patch that status. If you're running outside the cluster, then you need the RBAC, like you were saying, impersonation to whoever is I was going to say principal. Oh my God, I'm an AIM nerd. I don't know if other authentication system called the principal, but yeah, the subject, I guess, if I go to the tokens and cert.
Yeah. So, I mean, your RBAC, the thing with RBAC is that it separates out the role, which is, really the wrong term. It's more of a
Should be
permission set.
permission
Yeah,
set. I think that's a better name.
it should have been called permissions because role in the identity world, generic identity world, typically refers to a business function, not a list of permissions, but a function. So one of the most common ways that people describe it is they say, my role is accounts receivable. And then you set up permissions based on that role. That's where RBAC comes from, role-based access control. So I'm in accounts receivable. That means I cannot do things that somebody in accounts payable can do because you don't want someone who can write the check to also be able to cash the check. Um,
Yeah.
so, but it doesn't list a certain set of permissions. It's a description, and then each individual system is then responsible for tying permissions to that system. Now, in the generic identity world, people either love RBAC or they hate it based on, the generic idea of RBAC based on their own experience with it. I personally find that RBAC is a great way to start, but it doesn't really handle exceptions very well. And so like back in my day, I had multiple customers when I was doing, just generic consulting, you know, massive multinational customers. They even mention the term RBAC in any kind of generic identity. So, and you might as well just pack up and go home. Because there once upon a time, there were popular products around role mining where you would point this thing at your application. It would look at all the groups and what those groups could do and say, okay, these are the roles that you should have. Um, but Kubernetes kind of doesn't really do it that. It's really a permission list. And then you associate that permission list to users and groups based on your bindings.
And one question. So I think that the complaint that I've seen, and this is something that we're, at least at my job, we're trying to fix, not fix, but provide a solution with CDAR, which is an open source project to be able to, because we have a lot of users that come from a different, like you said, like depending who you come from which you come from an identity system or not. And I have a lot of end users coming from the cloud where they have AIM, and one particular feature that they have is based on attribute.
Yep.
Attributes like, Carlos can access me and Scott, Mark and me, we can both access buckets or like a resource, but I have a different role that I can access along that bucket has this attribute, and it could be my organization unit, or I'm older than Mark, or maybe Mark is older than me, right? And on an attribute on the principal, right? It could be an attribute on the principal, or it could be an attribute on the resource that you're trying to access. In Kubernetes, you just have the verb and the resource, but you don't say, well, I can access namespaces that have a label with Carlos, but not other namespaces. But Mark can access the namespaces also, but only namespaces that have label equals Mark, like owner, like it could be owner equals Mark. So it's attribute-based access. But Kubernetes had ABAC at some point. Isn't
sort
it didn't
of
have ABAC and then RBAC came in? I'm trying to remember the order.
Again, they didn't use the term correctly. What they called ABAC wasn't what you just described. Like what you just described is attribute-based access control. What the original Kubernetes ABAC was really just a CSV file that said this is what you have access to. It wasn't
really?
Yeah, again, they didn't use the term in a way that would align with the way industry uses it.
Okay.
So
I'm from RBAC and beyond. I never was aware of ABAC, but I was read that ABAC existed and then was RBAC. So it was more of an implementation of going of resources and role binding, that concept of role binding.
Yeah, it wasn't. I don't know why they called it ABAC because it had nothing to do with attributes. It was very static. You had to reload the API server in order to make changes. I mean, it was like their MVP, like version 1.0 nobody's really using this thing in production yet implementation.
And it was a CSV file that the API server read in
Yeah.
memory?
Yeah.
Like that to update it, you have to do what?
You
Do
have to edit
a
the
sig term?
file on the API server and then reload the API server. I
Okay.
mean, yeah. So
And if you
once
screw out
RBAC
that CSV
came,
file, the API server may not come up.
yeah, and even in the first two editions of the book, we mentioned ABAC just to be like, this was here. And with the third edition, it's like nobody uses this anymore. I don't even think it's even included. Like,
It's
I think
not
we're
included.
past
I don't think it's
deprecation. I don't
out.
even think it's enabled anymore.
Yeah, yeah, yeah. So yeah, I think
But
that's.
sorry,
Go ahead.
Carlos, want to interrupt real quick. So one thing we didn't do in this chapter, and the previous chapter, this is true as well. So with 1.28 or 29, two really important alpha features got added to Kubernetes. The ability to define custom token authenticator, or not custom token authenticators, but multiple token authenticators, and also multiple authorizers, and in a way that is much more dynamic, where you can define, when you want to apply the authorizer for, because maybe you don't want to apply it to all objects, and decided not to add it to the chapter because it was still alpha, and so it could change, and didn't want to put in print something that was likely to change. So I think they've been in beta since I think 30, and my guess is by 33 they've got to go production.
What they're called? Multiple what?
I have to look up the actual name of it, but
Authorizers, I think
it's the new authorization. So like that's how you get like what you were talking about with Cedar. That's how you use
I
Cedar as
see,
an
I see.
authorization.
Yeah, there's a flag that is in alpha, and that's why it's not in. That's why people cannot use it in ECAS, because that's something that it needs to be in the API server.
Right.
So when we enable it, yeah, we have to enable it in certain versions and up. Okay,
Right.
but
So
that's different from OIDC. I can have OIDC, multiple OIDCs with one API server, right? I can have like two because you mentioned that in the book.
Yeah. So starting with that's the alpha feature that went in 29, but it's the same type of thing where you need your provider needs to expose the ability to configure that, because it's not a etcd object, it's a static object that has to sit accessible to your
API server to read that information.
Right. So we will probably end up doing like a excursion on those two, because those are two really important topics. But we weren't able to, we'll get into the fourth edition in a couple of years. But we won't. We decided not to cover it here because it was just too likely to change.
Yeah, and it's alpha and it's not GA, so I think it's good to not include that. Then you talk about the roles versus cluster roles. So this one is that it's one that I see not confusion, but I usually highlight to folks that I like to use cluster roles as the primary thing. If I could avoid roles, I would, because then cluster roles is something that you define once. They're at high level, and you can use them in role bindings. And that's something that some folks, I think it's in the CK. I'm not sure if that's one of the questions, but yeah, a role is like you mean, it's a permission in the system. It's a permission set. But and then you can create a role binding using that permission set in a namespace, because it's a role binding that's applicable to that namespace. I think you have a little table that actually highlights that. But in what cases do you want to talk about, like what cases is actually useful for role bindings to exist at namespace level?
I'm not sure I understand.
It's not to City, it's to Mark or Scott.
So using a cluster role is really good when, like you said, when you have namespaced object, or you have namespace permissions that are consistent across all the namespaces. So as
namespaces,
an example, multi-tenant names in a
multi-tenant world where I live.
tenant cluster, right? You get the
Yeah.
admin cluster role, and then you just assign users to that namespace, to that cluster role in the namespace with a role binding, and so it only applies to that namespace. Whereas a role is really good where if I am a tenant and I need to be able to limit the ability of people to access things inside of my namespace, a role binding will work better.
Because
Because
it gives
I,
you
as the
that
tenant,
admin the
can create.
flexibility of creating that role, right? That they may not find a general purpose cluster role to
Right,
use, right? And then they have to create one that with a tweak or like a small change, and then they're like, ah, look, I have to open a ticket to whoever have
right.
access to
So,
the
like
cluster.
an example where I use role bindings a lot is I've got implementations of Open Unison where there are multiple Open Unison deployments in a single cluster to serve different functions, and they need to talk to each other. And so um, instead of like copying keys or certificates across, different namespaces, I write a role binding that says, okay, the Open Unison namespace one can read the secret that stores the TLS certificate in namespace two. And so it's very targeted, it's very specific. There's really no point to have a cluster role for that, right? Because it's very targeted, it's very
Ah,
specific. Because that's one of the things with RBAC that is important is you can not just limit the type of things you read, but you can also limit the specific objects that you read. So you can
so
say,
the
I only want my thing to be able to read these secrets, these specific secrets. And so now where that becomes important is, let's say you're running multiple things in a namespace. You're running multiple pods in a namespace. Now, a namespace is supposed to be your security boundary, but sometimes it just doesn't work that way. You can say, I can only read these three things. Be very targeted, least privilege. And that way, if that pod gets compromised, its service account can only read those three things, right? It can't go to the API server and say, hey, go give me, this other secret that I don't have access to.
that makes sense.
So,
That makes sense.
so
You
that's
can create
where,
like a role bindings that are very, yeah, dynamic in nature, right? So if you create a deployment, you can create a policy or like a convention that says, I'm going to create a deployment Carlos that can only read one secret name, resource name type secret called Carlos,
right,
right? And then
exactly.
that's it. That's the mapping. And you have that boundary, like they say, like you mentioned, it's a boundary on top of the namespace, where I can say, yeah, Carlos can have a deployment and secret Carlos. Mark can have a Mark deployment and Mark secret, but both are not. They're both on the same namespace, but just because they're in the namespace doesn't mean I want them be sharing or cross sharing the other secret, right? Reading the other
Right.
secrets.
Now, I
Um,
will put a caveat there. That only applies to API calls. So if you define a pod that mounts a secret that the pod service account does not have access to, the API server will not do anything about it.
it would not. It would not pop. The kubelet would not be able to populate the secret. I mean, that's what you're
No, it'll
saying.
populate the secret because it's accessing
Oh,
the
because it was
secret as
a
the
mount.
replication controller's identity, not as the pod's identity.
I see. I see.
There's
Cool.
nothing that stops, and replication controllers by their nature are privileged. So there's no way to stop somebody from mounting up. That's why the namespace is such an important security boundary.
Boundary.
Is if you use the legacy, I call it legacy, of mounting secrets directly into a pod, there is no security back. You would have to use an admission controller to stop that.
To
RBAC won't do
stop that to that configuration of the volume mounting, right?
correct.
the pod inspecting it, and something like OPA or Cuverno or your home webhook. And that goes the next topic of the negative roles, right? There's no such thing as saying, yeah, you can do everything except, and I think you go beyond explaining like why is this in practice a bad thing, right? A kind of an anti-pattern.
Yeah.
I recall.
Yeah, negative roles I would definitely call an anti-pattern. It's one of the most asked for things when people are like, "Oh, I want to be able to write a role that says people can, edit everything except these three objects." And it's a really big anti-pattern, especially in the world of operators and CRDs, because if I say I can do anything except this, I can do anything except access the kube system namespace. Except that also includes creating CRDs that there could be some operator that I'm not accounting for in the future that has global access to those CRDs. And so here I'm using the example that Amazon has a way of creating AWS objects using Kubernetes CRDs, right?
Yep,
And
yep.
that's a great model, but you have to add security on top of that. So if now I've written this RBAC that says everything except these three things, and now somebody deploys this AWS thing that is not one of those three things that isn't explicitly not allowed, now I've been given access to it.
I see that point. I was reading the CRD and the AWS resources, but it's so it becomes a system of an allow only system. Like
Right.
like if somebody asks for that, like rephrase the question instead of with only or except, rephrasing it like, well, just give it access to the three things. Like don't worry about the thing that you want to negate.
And
And
and the
resources.
next thing, another way so there are now two ways to handle that scenario. One is what you're about to touch on, is aggregated cluster roles help there, because now you can more dynamically generate your cluster roles. But two, the dynamic or the custom authorizers that now exist that we talked about, like using Cedar as an example,
Yeah,
you could add that logic in.
I see.
And I guess the third way to do it, and this is kind of a hack because it's not entirely true because it doesn't work with reads, but the way that people have done this in the past is also with admission controllers and building in that custom logic.
I see. Talking about aggregated cluster roles, this my perception is it's not a well-known feature that people know. Like it's something that I don't hear a lot, and also I could be wrong, but I smell this that in some cases could be a foot gun, because it feels like a super easy way to give more permission to an existing role. Like people coming in that may not be aware of this feature, they might think, well, if I create a role and these are the rules that are in that role, yeah, nobody can modify until I come the next day and have to edit that role. But suddenly now this feature say, no, by magic, these rules can grow by just someone having right access to create any cluster role, as long they put the label matching here. So the door is down there, right? The cluster role needs to say, I'm allowed to be in, like I'm allowed to somebody else to create any cluster role with this label, and I just get augmented. Is that opens the door for a foot gun, or it's like a good thing, a bad thing, or just be cautious?
But the upside to that, so let's look at it from a different direction. The admin cluster role. Okay. If you look at the admin cluster role, that is actually an aggregated role. That is not if you look at the cluster admin role, it's just star, right? You can do anything you want. But the admin role in a namespace does not allow you to edit any namespaced object. It doesn't allow you, for instance, to edit resource quotas, right? Because in a multi-tenant system, I'm a tenant in a namespace. Even though resource quotas live in my namespace, you don't want me to be able to edit it because that impacts the entire cluster.
I see.
So even as an admin, I do not have the ability to change. I don't have the ability to change a admin resource quota object in my namespace. So now let's go back to the operators concept. Kubernetes is extensible. I've written an operator that lets me, request S3 buckets. I'll just make that one up. Okay.
Yeah, you have the
And,
super widget example in the book for that
yeah.
one.
I've created this operator that lets me submit for a super widget. And, I want anybody who is a tenant to be able to do that. Right. So the first option is I can go create my own cluster role. And then I have to put a role binding in every single namespace. And that's a pain in the butt. I could go edit the admin cluster role and manually put it in there. But the thing is that cluster role is generated by whatever deploys my Kubernetes.
Yeah, it's a system. It's a system one that people should not be
right?
editing. Yeah.
It's going to get overwritten. But if I define an aggregated cluster role label, if I put the right label on my cluster role, now every admin in my cluster is able to create the super widget.
So that's the reason that the system, when you deploy Kubernetes, in most cases, it comes with these default roles: admin, edit, and view.
Yep.
And now you, as a CRD, by creating a new type in the system, you can say, well, I'm going to create a cluster role with this label to allow to add my stuff into the view one, to allow my stuff into the edit one, allow my stuff into the admins. That the pattern?
Exactly. So edit is admin except no RBAC. You can't do anything with RBAC inside of your namespace. So if you want to have that, if you want to say, okay, we want to let admins have access to this, but not editors. And I'll be honest, in practice, I don't see a lot of edit, but it's an example. That lets you kind of differentiate a bit. And then you can define your own aggregated cluster roles as well if you wanted to.
Okay. So and at scale is keep it dry, I guess. It's a form of keeping it dry.
Exactly.
Not repeating and repeating over and over. And it's a way that you can subscribe, or like, here's extra rules for new types that you're not aware, that I want an admin to be aware, and the type of permissions you want, because it's the full rule, right? Including the verbs. Yeah, I want to jump to the last the section that talks about audit. So and then for those of you that have the book, this chapter is very interesting because it talks about the how to identify an end user that when you come from the outside OIDC, or in the RBAC, that is not to identify two different users in OIDC. But when it comes into audits, this is this audit, for some reason it crossed my mind, this is like the audit log policy, right? This is not a CR. This is configuration, I would say, right? That looks like a CRD or a CR.
It does look like it is YAML.
Yeah, it
but
does have metadata, yeah, but it has an API version.
Yeah, it's not something that gets stored in etcd. It's something that gets stored locally, much like your some of the other configuration files, like the cluster configuration and whatnot. They're local YAML files that get stored on the hard drive, basically, for lack of a better word, that your API server is running on.
Yeah,
and so
then go ahead.
So that means, like, we're using kind in kubeadm, and since when you're running kube on-prem, at least, most of the time it's running in a container, right? Like it's running in a static container. So you actually have to mount the directory that stores the policy file and the directory where you want the logs to go as a local mount into your API server. So that's what the lab is.
Yeah, it goes over like editing, and I think this is well, it is part of the CK cert to learn about this and actually configure it. One thing you have to watch out is in enterprise settings is one the running out of disk space.
Yep.
Right. Configuring that. And then the other thing I was looking at just to share with folks is in enterprises, people use cloud Kubernetes. And in some cloud Kubernetes, you don't have the luxury, or not luxury, but you don't have access to edit that policy file. So I'm showing here one example of EKS in AWS. There's an audit policy already in the system, and you can see here of like what are the things that it doesn't log for performance reason, or like too much information. For example, if you're going to um, uh, log everything, but at the end it logs a lot of things. Like it logs the request, and those for you that have studied for CKA and the Kubernetes, request meaning like the type of information that goes into the file in the log is the input request, but it also has a request response, which is the output. So if you do a get, right, the output will come back and it will be logged. So there's like all these groups get log. So so it's done here, and it's in AWS and EKS. These logs go to CloudWatch. It's a system that has in AWS. It's called CloudWatch. Just a few tips out there is if you have a dev cluster or things like that, you might not want to enable this because then you incur into charges in CloudWatch. Another thing is like you validate like the retention. Like sometimes you can put a very short retention, like 1 day or a few weeks, depending your regulated environments, that you may need to keep backups of the log for a long time, and there's ways to put it in another system. But for a mapping of like, you read in the book, what Scott has is something like can kubeadm. You can edit the API server like normally Kubernetes. In cloud systems, you may need to use the login system that they have. And one thing that Scott mentioned that I think it was very cool is to use a tool. I think it's Audit to RBAC. Is it?
Yes.
Yeah, Audit to RBAC. And it goes through, actually goes to an example of like, if you're trying to troubleshoot why something doesn't work. Mark shows an example that is very, I like that you actually put examples that are very real. Like you put an example here. I think it's a Prometheus service account. When you're using Service Monitor, that controller service account needs access to list the services, and you can spend the whole day figuring like why it doesn't work, right? And then you show that you can actually go to the audit logs and say why is not working, and it could be like the controller, right? I think this is a good. I love that you have this in the book, because it shows you two things, right? It shows you like when if things are not running, usually what do? You go to get the controller logs, and the controller logs, what it could say is like, I don't have access. Well, what type of access do you need? Is it a get? Is it a list? Is it like what type of access? And then the audit logs is the one that will give you that information. And then this nifty little tool, you can give it like an audit log that has errors, and it will give you back kind of like the YAML, right? Is this the YAML that give you back? Yeah, you run it with this file, and then it give you back the what could be a role and a role binding, right? And you mentioned here like don't take verbatim whatever this tool gives you. Like it's a starting point, because you may need to modify, right? Maybe not give access to that specific user that was trying, but maybe the group instead, which is more best practice to do that. I was trying to use this tool with EKS, but I couldn't because the logs are in LogWatch. So I was trying to figure out, yeah, there's you need to extract them from CloudWatch and put it in the format that the audit to RBAC was using.
I will say that the the error messages have gotten much better. In previous editions of the book, um, we had mentioned the fact that you don't get enough information from the error messages when you hit the API server to actually write and fix it. I want to say it might have been
in the audit log. You mean like the audit log
no
has more context?
HTTP response. So when you
Oh,
did
the
it,
HTTP response.
do something, you would get an error back that didn't
4.3.
actually give you enough information to correct the RBAC. And I want to say it was somewhere in the 15, 16 timeframe that it was between the second and third book, where they corrected that, and so you now get enough information in the error at the HTTP level to actually update your RBAC
Figure out
binding.
what is the URL. What is the URL, and then from that work backwards to
Exactly.
compose the verb and the resource. But take into account that, for a good reason, sometimes not authentication, right, is a good thing to not have information in security, right? Because they want to
In
hide.
that particular instance, I honestly don't think that, and this is why they probably ended up putting in there. They're not doing anything other than spitting back to you information you already
You're
provided.
sent. Yeah.
Yeah.
Okay.
So they're not saying here's their RBAC binding. They're saying
You
your
try to
user
access
that
this
you sent
specific thing.
us doesn't have access to the URL that you wanted.
I see, and then you can
Right.
figure out
So
the rest.
it's only information you've already given them. It's not, you can't discover anything new about that.
Yeah. I want to share some resources I found, other tools. I put it in Slack also, tools that I found online that I was like looking like, well, if in a cloud system, how people would do it to find like audit, or there's only RBAC tools. And I found this one, Managed Kubernetes Audition. I think this is from Datadog. And then this one specific to cloud providers that will give you like this service account has access in this, like that, this mapping of like pod identity and things like that. And I found other ones like one that is like based on doing OPA policies. It's called RBAC police, and it's funny because it's like it uses OPA policies to check your posture, right, of this RBAC configuration. Because in a large system, it's kind of like quite difficult, right, to go one by one to know like the complete view for this user. So, for example, simple questions like, what does Mark have access in this cluster? Like, to a bunch of things. They're in our RBAC YAML file. So we need to find where Mark is part of which group and where Mark shows up, and then collect all that information. And then hopefully I'll give you like those Mark has, like building the engine, right? The engine is the only one that can do an execution time. But for auditing, I think there's a lot of tools, right? And vendors that have support for like verifying the RBAC configuration in your Kubernetes cluster. So these are some of the open source tools I found. I wanted to share. I think we're running out of time, but yeah, that was RBAC and on audits. Thank you, Mark.